Okay, I'm going to talk, good morning everyone, first of all. I'm going to talk about not only how and how we can start this, but why should we want to start this. And I'm going to do it from the context of where most of my experience is, which is in aviation safety. The reason we want to start this is the pleasant surprise that we discovered when we started a safety program in aviation, and it really was focused primarily on safety because there's so much public fear of flying that we get more media attention for an airplane that slides off the end of the runway and people go down the slides and sprain a few ankles. We get more national media on that than 50,000 people dying on the highway every year. So that's the safety goal that we had. But here's the why that we discovered as a pleasant surprise is that improving safety usually is associated with hurting the bottom line, and the pleasant surprise was that it usually does. But guess what? If you do it right, it actually improves productivity. So that's the why of getting started, and that's what I want to talk about is not only how, but the why. And here's no secret. Here's the ingredients of this process of safety improvements that also improve productivity. It's a two-piece thing. One piece is the system think, and I'm going to talk about what system think means. And the system think process is fueled by information from the front lines. And what we found is when you take system think as a process and fuel it with this information, then we not only improve safety, but we improve productivity. So the emphasis is, yes, generally the history shows that improving safety hurts productivity. If we do it right, however, improving safety can also improve productivity. So I'm going to talk about the context in which this occurs so that you can see if this context applies to your situation, and then talk about the system think and the frontline information, the benefits that came from it, and show the specific successes in aviation. And then here's the how part. What do the leaders do to help this happen? What does the regulator do to help this happen? Because most of these industries that I'm talking about will have a regulator or more than one regulator in the case of healthcare. And then, in my case, since I'm at the National Transportation Safety Board, what can we do to help this happen? So, first of all, I want to talk about some definitions. What do I mean? Well, when I talk about reliability and we talk about high reliability organizations, all of this conversation for most of the industries I've talked to, and I've talked to chemical manufacturing and nuclear power and even the banks, the financial industries, and that's because they all came to aviation and said, wow, how do you guys manage risk as well as you do, and what can we learn from what you did to manage risk as well as you do? So in all of those instances, and of course the big 900-pound gorilla that we all know about was healthcare, they're all looking at how to get more output without adding more input. And so in that context, reliability, what I'm talking about, reliability, is not breaking down. When I talk about safety, I'm talking about not hurting anyone. And when I talk about productivity, I talk about the ratio of output to input. And then when I talk about quality, that's kind of all of the above. Now, how are these related to each other, generally speaking? Well, generally speaking, quality is kind of the background, all of the above. But what we typically see is there's usually a positive correlation between safety and reliability. Not always, but usually if something is more reliable, it's also safer. If it's safer, it's probably also more reliable. And that's why I put parentheses around it, because it's not always, but it is usually. What's the relationship between reliability and productivity? Usually that's a positive correlation as well, that when you improve one, you improve the other. But the usual correlation between safety and productivity is the wrong way, that when you improve one, you reduce the other, and vice versa. Now, what I see the relationship between all of these graphically is it's a three-legged stool: reliability, safety, and productivity, that produces the quality, the bottom line. Now, here's the context in which this occurs in our industry, and I'm going to bet that in many of your other industries, certainly the ones I've seen, healthcare, nuclear power, chemical manufacturing, it's the same kind of thing, where there's a system that consists of lots of pieces that are related in various ways, sometimes tightly coupled, high-tech components, a lot of innovation going on in all the pieces. And so what that results in is that safety issues typically are not stovepipe silo things that are just software or just equipment. Usually safety issues are interactions between all the pieces of the system, and the interactions ain't working the way they're supposed to, and that's why there's a problem. So what that means is, first of all, it's good news and bad news. The good news is the systems are usually sufficiently robust that it takes more than one thing to hurt somebody. But the bad news is that means there's no simple place to intervene and say, oh, here's where the problem is. If we fix it right here, we have fixed the problem. Well, usually you haven't, because of the complex interactions it takes. It's usually not a simple fix in one piece of the stovepipe. It's usually related to the interaction between the pieces of the stovepipe. So in that increasing complexity, that increases the opportunity for human error in at least three ways. First of all, just because it's more complicated in general. But second of all, because what that means is that it's so complex that the people who design various pieces of the system don't necessarily have an appreciation of what the role of that piece of the system is in the total environment. So oftentimes the operator, the frontline operator, is encountering a situation that even the designer didn't anticipate. And that means in our business, we call that a test pilot, and we don't want test pilots flying airplanes full of people. So we see increasing complexity increases the likelihood that the person at the front line encounters a situation that wasn't anticipated by the person who designed it. Now, a variation on that theme is the people who designed the book on how to operate this thing also didn't necessarily appreciate the complexity of how this piece was going to fit in the total system. So sometimes the experienced operators say, well, I can do it the way the book says, but if I do it this way, it's even better, and I can do it better. And that's what I like to do because I'm good at what I do, and I want to do it better. And the people who designed it, who sat at their desk, had no experience with how to do it. I do, so I'm going to do it in a better way than they wanted me to. So that's one of the many ways when you hear about workarounds, when they don't do it the way the regulator said by rule you ought to do it, or the person who designed the book said you ought to do it. They do it some other way because they know from experience that it works better. Well, when all those things, those three different examples work, we never hear about them. But if they don't work, then we call it human error. Then we blame that poor operator who tried to do it the best way. So that's what we're trying to get around is how do we address this situation where this increasing complexity results in the problem that the frontline workers who are highly trained, competent, proud professionals and trying to do the right thing, but they still commit human error. That's the challenge. And that means a mindset shift from where we are today, which is, boy, we put a lot of money in training you, and if you had absorbed that training, you would have gotten it, so apparently you weren't careful enough, so it's time to punish, time to slap a wrist. Okay? Well, that's the old day. What we need to do is start shifting our mindset to, guess what? You're a human being, and we all know what that means. That means you're going to make mistakes. Okay? So that means we need to think about two things. One is, why did the system allow that mistake to be made? Why wasn't it designed more robustly to decrease the likelihood of mistakes? And then number two is, why wasn't it designed on the assumption that there will be mistakes? Why wasn't it designed in a way that can accommodate that mistake without catastrophic consequence? And let's see if we can use that to improve the system. Now, note that I didn't say ignore the operator. I said also look at the system, because the operator is always, always, always ultimately accountable. So that's not a get out of jail free, and that's one of the criticisms we often hear. Oh, this is get out of jail free, look at the system, ignore the operator. We do not ignore the operator. The operator is obviously a crucial part of this. We look at the operator and the system, and what we really look at is the interaction between the operator and the system, because if we see people tripping over the step X times out of 1,000, and we ask how big does X have to be before you stop saying, operator, you're clumsy, and start looking at the step, well, the reality is the problem is not the person or the step, it's the interaction between the person and the step, the interaction between the person and the system. And if we don't recognize that interaction and say, well, gee, instead of just saying you're clumsy, maybe we ought to light the step, or put a ramp there, or put a warning sign or something, but not just you're clumsy, because just you're clumsy does not fix the problem for the next person who's going to go over that step. So the real issue is not the person or the system, the interaction between the person and the system is the issue. And the question is, how do we learn more about that interaction? And the way we learn more about that interaction is by collecting and analyzing and sharing information. So that's the that's the enormous success that's been enabled by these amazing IT advances that have created enormous abilities for us to collect and analyze and share data about things that happen every day, so that we can help spot precursors and try to figure out what's going wrong and know it on a daily basis. And the objective of that collecting and analyzing and sharing information is twofold. First, as I said, to make the system less likely to cause error in the first place, and second, to make it more tolerant when error does occur. So we look at the Heinrich Pyramid, and you've seen all this. I don't need to go over it in the shortness of time. I won't, but you know, for every major accident, you'll have 5 or 10 or 15 incidents, but you'll have a whole bunch of unreported occurrences, and the information collection that I'm talking about focuses primarily on these unreported occurrences that the frontline worker bees know about because they live them and breathe them and do them every day. We're trying to figure out ways to get that information into places where people can fix it. So most of the industries that I talked to started that effort by looking at near misses, which would be the unreported occurrences that are the most serious of the unreported occurrences. Because every industry I've seen has some kind of reporting program with a line that divides. Above that, you got to report it. It's a mandatory report. Below that, it's voluntary. The target that I'm focusing on is the voluntary stuff, because that's the building blocks to tomorrow's accident. That's what we're trying to learn more about, but we know that we're not going to get that information unless these people are comfortable with it, because they're the ones, and as an NTSB, at the NTSB, every accident we had, the frontline people always say, yep, we all knew about that problem, and guess what? We knew that sooner or later it was going to hurt somebody. Okay, so then the question is, why didn't we fix it before it hurt somebody? Well, because there are lots of reasons why that information stayed in the crew lounge, so to speak, but never got beyond that to get to management where it can be fixed. Public disclosure, fear of your name showing up in the newspaper because you made a mistake. Job sanctions, I'm not going to report this to my boss because it might be used against me and I'm going to lose my job or my promotion or whatever career advancement I want. Criminal sanctions, I certainly don't want to go to jail, and if I report this stuff, I might. And civil litigation, nobody wants to have that come out and be used against you in court. Excuse me, in court. So there's lots of reasons, and we've made major progress, and it's helped that I'm an attorney because I've been making lots of progress on these legal issues in aviation, and we've made major progress on that to address each of those 4 legal issues. In fact, we did it so successfully that now we're seeing cultural issues that we didn't anticipate, and the biggest cultural issue is the fact that the boss is always in the media saying, oh yeah, safety, 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 that's what we want, number one. But the frontline employees, guess what their number one goal is? Their number one goal is to please their boss, because that's who determines their career future and their raise and what happens to them. Then they'll think about safety. But here's the problem, is that the person in the middle, their boss, probably does not have a safety metric in their job metric. And that means they care about production. So if the person from the floor comes to them and says, boss, I got this problem that could be a safety issue, if that interferes with the production metric, which is what determines my raise, and I'm in middle management, I'm going to say, don't bother me with that, go fix it. And that's another way you hear about workarounds, because the people on the floor, who, by the way, in many cases like ours, can be hurt by their mistakes, and so they really want to fix them because they don't want to get hurt. Well, they go to the boss, and the boss says, that's going to interfere with my production metrics, so don't bother me, go fix it. That's another way that you hear about workarounds. Okay, so what we found is that that you see safety mentioned at the top, you see safety mentioned at the bottom, but it gets stuck in the middle because middle management does not have a safety metric in their job metric. So that's a huge issue that we see in trying to get this moving. So what we found is, as we made a lot of good progress on the legal and cultural issues, then we found there were some more issues that we didn't anticipate, and that is, wow, now we're starting to open up the pipeline and collecting all this information. What are we going to do with all of this stuff? And so that means the improved analytical tools, because here's where we are today. We've got much more information than we'll ever have tools to deal with. And in fact, we've got this problem so much that a lot of people are saying, why should I even bother collecting the information, because you can't help me use it once I've got it, so I don't even want to put the time and money into collecting it in the first place. And that's a huge issue. And that, in fact, I consider that even a more serious issue than the legal and cultural issues, because we've got the capability to collect, I mean, one flight from here to Paris and you got a room full of data just from one airplane right there. How are we going to use all this stuff and try to mine it for, sift all this gravel for the little nuggets of gold in there that are the precursors for something that could go wrong? You saw that in this thing with Detroit. How many people were there on the FBI's or the international security agency's watch list to try to find out, this guy might try to do something stupid to an airplane, might try to blow it up? How many others do you suppose the FBI had that they were also looking at? Well, we'll never know that, but the point is, there's lots of information out there, and we got to get smart about how to use it wisely. And the trick is getting data from lots and lots of sources, starting with the front line. The front line has to be a crucial part of that source because they see it and live it and breathe it every day. Get data from lots of sources, apply tools and processes to that data with smart analysts to do 4 things. 1, identify what the potential issues are. 2, prioritize, and that is by far the toughest part of this 4-piece assignment. Number 3, once you've prioritized and decided what goes in the front burner, then develop solutions for that. And number 4, which is very crucial and I see too little of, evaluate whether your intervention is working without causing other unintended side problems that you weren't aware of when you started this. So the evaluation and the feedback is crucial. So identify, prioritize, solve, and evaluate. Well, the prioritization is tough, and again, in the shortness of time, I won't go over these in any great detail, but I'll just give you some examples of places where we look back in hindsight and said, guess what? I don't think they prioritized this very well. Okay, so there's the space shuttle crash. There's the Concorde, had the tire explode. They had previous tire disintegrations on takeoff, and what did they do about it? There's the Ford and the Explorer and the Firestone tire. I mean, they had previous instances of that. There's then the famous case of, gee, people are learning how to fly. They want to fly these simulators in Arizona, paying cash for it, by the way, but they don't want to know how to land the plane. So, okay, people report that to the FBI. Guess what, boss? There are people who are flying these simulators with cash, but they don't want to know how to land the plane. Okay, well, that got reported to somebody, but how many other problems was the FBI looking at? And in those days, we had no clue that that meant here are some people who are trying to learn how to fly airplanes into buildings. We didn't know that. Well, guess what? We didn't have at that time. We didn't have the experience to know that that's what they were trying to do, and that's where hindsight plays the crucial role. The key question is, how do we prioritize these things without the benefit of hindsight? That's the tough part. Now, let me talk about successes. And in aviation, we had an amazing success because we applied this process of system think fueled by this IT revolution, the information provided by the IT revolution, and achieved a 65% decrease in the accident rate since 1997. And that's because of the combination of system think plus the information. And that's amazing in and of itself, but all the more amazing because in 1997, we were already considered to be a very safe industry. So that's, to me, a benchmark of how successful this combination of system think plus proactive information programs can be. Well, how did we do it? Well, the system think part, there's a couple of ways to do that. One is to have a very, very, very smart person who appreciates all the pieces of the system. And we heard in the previous presentation about the importance of including the pieces of the system. Well, that's one way to do it, but these systems are getting so complicated with that drawing that you see there that there usually aren't that many people. We're having more and more difficulty finding a person who is so smart to understand the ramifications of the system. So the way they did it in aviation was by bringing the players to the table and sitting them there at the same time. So now the airlines, the manufacturers, the air traffic organizations, labor, management, everybody is there at the table at the same time talking about what are the problems that we face and what can we do to solve these problems. Now, this was a historic endeavor because these are typically players that do not trust each other and rarely play together. They don't trust each other in lots of ways. I mean, you know why they don't trust the regulator, because the regulator was created to regulate and enforce. So that means, by definition, that's an adversarial relationship right there. So nobody wanted the regulator at the table. But guess what? The operators and the manufacturers don't like each other either, because if there's a crash, they are co-defendants and they're fighting against each other. So they don't want to work together either. So this is historic in the leadership that it took to bring all these players to the table to recognize that in their enlightened self-interest, it's a better result to work this out together than to do it the historic way. The historic way was the FAA, as the regulator says, do this, and everybody grumbled and groaned and appealed and litigated and this, that, and the other, and maybe did a little bit of it. Well, now, what comes out of this pipeline has the ownership interest of everybody at the table. And not only that, but because it has the ownership interest of everybody at the table, if you assume that this system is so complicated that you didn't come up with the right solution the first time, it's going to need some tweaking, these people need to be there to help tweak it. They are not going to tweak it if the FAA says, you must do this, and they groan and grumble and don't want to do it. They will tweak if they do it this way. So that's what provided the system think, and that was an amazing success, and I would suggest that other industries might want to look at. In fact, I would wonder if the mortgage banking industry had collaborated with the securities industry when we were going down this path called securitization of mortgages. I wonder if we would have been in the meltdown that we're in today. I just don't. I mean, it's that powerful, and it's so powerful that it took an already safe industry and improved the safety by 65%. Now, you can have system think at an overall system level. You can have system think at a much more micro level, too, and I'll give you an example of how it worked in our industry at a micro level. At a micro level, the airlines buy airplanes mostly from two major manufacturers, Boeing and Airbus. Okay? Now, Boeing and Airbus used to just build airplanes and throw them out there and say, okay, pilots, fly them. Well, they found out there were a lot of disconnects when they did that, so guess what they started doing? They started bringing in pilots from the very beginning of the design process. Step number 2, these airplanes have to last 40 or 50 years, so they better be very easy to maintain or they're not going to last 40 or 50 years. So if you take your car to the mechanic and say, replace the spark plugs, and the mechanic says, oh yeah, I'll do that, but guess what? In order to replace your spark plugs, I have to take the engine out of your car. Wow. Look at how inefficient that is, and look at how many opportunities for errors that creates, because I have to take the engine out of the car to replace the spark plug. So things that are ordinary periodic functions better be easy to do, or else it's not going to last for 40 or 50 years. So they bring in mechanics from the beginning. Okay, here's real system thinking at its finest. Most of the life of an airliner is on automatic pilot. We saw that in Minneapolis when they flew past Minneapolis because of the automatic pilot. Okay, most of the life of these airplanes is on automatic pilot. That means if it's going to fit into the system, the automatic pilot better be able to easily do what air traffic controllers will typically ask it to do, or there's going to be a disconnect. So they would bring in air traffic controllers from early on in the design process to say, will this work? Will this fit into the system? So what they did was they looked at friendliness from 3 different perspectives: user friendliness, maintenance friendliness, and system friendliness. And that, again, I commend that to all of you industries to see if that's something, because I tell you, in healthcare, I saw absolutely none of this participation by the manufacturers, bringing in the end users, bringing in the people who maintain it. I saw none of that in my looks in healthcare. So what we see is, yep, sure. What we see is now these programs that were created to improve safety are having amazing savings in operations and maintenance, and the savings are much more than the usual metric we use, which was what we don't spend because of the accident we didn't have. We're finding out this gives a much bigger bottom line, and plus it's more immediate and more measurable than trying to measure the savings that you had from the accident you didn't have. So why do we always say improving safety is going to hurt productivity? Well, I'm going to just go these briefly because I see the cane is about to snatch me off the stage. We see the difference between safety poorly done and safety well done. Okay, poorly done, punish or retrain the operator. You see that all the time. Well done, look beyond the operator and also consider system issues. And I don't have time to go over all of these, but these are the many costs, the many ways that you can hurt your bottom line by doing it the wrong way. I mean, just start with morale itself. I won't go beyond that. I'll let you read it, and the slides are available to you. But there's all these costs that are associated if you do it the wrong way versus if you do it the right way. Safety poorly done. Management decides remedies unilaterally. Oh, I'm smart, I can figure this out. Well, what you need to do is you need to bring the worker bees who live it and breathe it and do it every day and let them help to identify what the problems are and solve them. And again, there are lots of problems associated with doing that the wrong way. The third one is do it based on your gut instinct instead of real hard evidence. Okay, and there are lots of costs associated with doing it that way. Last but not least is you do an implementation and then you sort of say, okay, we took care of that. But you got to evaluate whether the implementation is working, or else you're going to have it again. So the bottom line is safety good business? Well, typically it's not necessarily good business, but it can be if you do it the right way, and this is the right way. Okay, now we're coming to the end. Who does what to make this happen? Leadership, first of all, it's got to start with leadership. But if they say no errors on my watch, guess what? They're not going to hear about any errors. So they have to do it the right way. They have to show their commitment, but they can't say no errors on my watch because that's going to kill it. Okay? It has to include everybody in the system and not just management. It's not you guys are the problem, so we're going to retrain and retrain and retrain you guys and fix the problem. It has to be we are creating the system in which you guys are trying to operate, so we know the problem has to involve a solution that involves us and not just you. You have to engage labor from the outset to help create that solution. You have to make safety a middle management metric. I showed you the slide on that. Engage labor early, I mentioned that. Include the system, and then encourage and facilitate feedback and make it so it can really happen. Now, what can the regulator do? Well, first of all, the regulator needs to encourage and participate in this system think process, but the regulator also needs to define the policies regarding protection of this information so that people will not be afraid to provide it. What can we do? Well, right now I'm trying to I'm here today because I'm trying to encourage cross-industry sharing of notes on how to do this, but in addition to that, I see the number one biggest issue that we're all facing in order to keep this train running is how do we prioritize this stuff? How do we develop a robust, objective, repeatable prioritization process? And I am now in the process of getting together academics, other industries, other countries, bring them together to brainstorm on how to develop a robust, objective, repeatable prioritization process. So that's why I'm excited to be here today. Thank you for your time. Sorry I overran. You know I'm a lawyer, and a lawyer's number one credo is never use one word when two will suffice. So I tried to be brief. Thank you very much.